See that? So the particles are being created and pushed into let particles. And here, it's looping through the particles and showing it on the canvas and updating it. Let's go to the update function. The update function, here we go, here's the update function. So it's randomizing the particles over time using this stuff here, which is using a Vx is velocity. Velocity on the x-axis and velocity on the y-axis. And it's adding it to this dot x and this dot y, which is the position. Okay. So if you look at this particle class over here, you have this dot vx random, this dot vy random. So that's the velocity, like the speed. And in the update function, that's where it's being pulled together, added together. Yeah. And also we have I've also put the alpha, this alpha.
How often does the update function get called and where?
It gets called, where does it get called? It gets called, here's it, here. You can see here.
Yeah.
That's where the particle gets called. And then it gets shown. It gets shown. What else is new? Okay. But there was one problem there was a problem with this. Every time it was called, it never was deleted. So if I go back to here, see the particle. If we go to inspect, console log, particle length, that's it, particle length. Particle
260.
length, yeah, L-E-N-G-T-H. Is that going to work?
I think it was particle.
Yeah. So it's 260 particles. Let me do it again. Well, it should go up. Okay, so it's 260 particles. The reason why it's staying at 260 is because I have a function that deletes the particles over time. Where am I? That's not what I want. Let's find that function, which is finished. It's called finished. Finished. And finished is here, or is it? There's the function that's being called. So it's controlling the alpha. So when it gets to the alpha is the transparency of the particle.
Oh, right. That's the same thing here.
Yeah, the transparency. So if it's below 0, return finish. Just finished. Particle splice. Splice, this actually takes out the particle from the, I think it's the array. Yeah. So particles.splice takes a particle, one particle out of the array. So that gets removed. So it removes the element. And if this wasn't there, it would just carry on growing and growing and growing, and it would just continuously grow
until
infinity. Until it crashes, maybe.
Until it crashes. Yeah.
Until it crashes.
Can we see it? Do you want to comment it out?
Okay. Let's see it crash.
Take all your RAM memories.
I assume so. Yeah.
Okay. Just keep going. Saves. Saved. I need to
There you go.
refresh. Not this one, not this one. Window. Inspect. Shit. There we go.
Yeah. Then do it again. Yeah. Climb.
And it's climbing.
Okay. Let's stop it now.
And it goes on and on and on. Let's stop this here. Stop the particle. And go back to desktop. Okay, Phillips. That's it.
That's pretty much it, is it?
Yeah, that's pretty much it.
Okay. Questions for Kieran?
Could you explain
Letter.
Which one?
Draw.
Draw. From draw. The draw function.
Yeah.
So the draw function is allowing these particles to be drawn onto the canvas. That's what that is. But this actual draw function is part of the library. So it makes these.
Part of P5.
Yeah, P5's library. Also, the show function and the setup function is part of the library as well.
So whenever you're working with P5, you need those three functions.
Yeah.
At least, yeah.
Yeah.
So background 0 just means set the canvas to black, right?
Yeah. Yeah.
And you've got your loop. You want to explain to Jack what the loop does?
Okay. The draw loop, Jack.
Yeah.
Okay. So what this loop is doing is creating a particle 5 times on every frame. So on every frame, 5 particles are being spawned. And then it's being pushed into an array. Particles being pushed into an array, which is declared at the top of the, up here, at the top of the page. Any other questions?
I guess for me, the particles at the moment, they're appearing sort of down the bottom and it looks like they're shooting up,
Yeah.
like a firework or a gun
Yeah.
or something. So what part of the code tells it to shoot up?
Up,
like
okay.
That, in that
There
direction?
we go. This part of the
Oh,
code.
the velocity. Yeah.
So we got that's where it starts, 300 and 380. X-axis 300, Y 380. Velocity.
So X300 is going to be the middle of the canvas, right? You have a 600
Down.
canvas width, so it'll be the middle.
Yeah.
And then the Y300?
Y 300 is.
Why is that at the bottom? Does it count from the top corner?
Counts from the bottom and goes up.
You've
Can I
got
explain the canvas? The
of
canvas.
Y400, haven't you?
Can I explain the canvas? I'd have to explain.
What happens if you
Canvas.
change this dot Y to
Let's change
10
it.
or something?
Okay.
Where does it then appear?
Let's do that now. Let's put this back in to effect. So change this dot Y
Yeah.
to like. Let's give it a
Curious
random
why it's at
value.
the bottom of 300.
Let's change it to 450 maybe. Yeah.
Bigger than your canvas, isn't it? Or not?
It's moving it. It's moving it on top of the canvas. Okay, let's
Okay,
try
let's
this.
see what it's done.
Desktop. Oh, I closed it, didn't I? Closed it.
Go to desktop.
Oh, there we go.
We haven't
Double.
got infinite. Yeah. Just open that in Chrome. Right click. Oh, yeah. So now it's moved down.
Yeah. Okay.
So it must have started counting your Y at
Right.
the top, right? Sure.
Yeah.
If you put
Mm.
Y equals 10, it will be up here.
Okay. Just pushed it down. Yeah.
So I think your x0, y0 is probably the top left
Top
of
left.
your canvas, based on that. So if you give it a number that's inside your canvas now, you'll see the whole thing again.
Give it a.
If you put
number.
200, it will start in the middle, right? If my theory is correct.
200.
Yeah,
On the Y.
200.
Right equals 200.
And go back. So,
Yeah.
now
Okay.
it spawns in the middle, right? The very
Yeah.
middle of the canvas. I guess if you change the velocity, it would go in a different direction, right? You
Yeah.
give it a plus rather than a negative, and it will spout out in a different direction.
Should I do that?
Cool. Impressive, right? All of what you can do with Canvas fairly easily in JavaScript as well. We recognise that as well, hopefully, as being JavaScript, right? Classes, creating each particle. So it's a really good use of classes as well.
Yeah.
Every single particle is the same. Yeah, so why not create a class of it and then a new instance of a class each time we want a particle? We ended up with like 4,600 or something particles, didn't we? And all just from one class. Whereas if you think we had to write that 4,600 times,
Crazy.
nonsense, right? So this is object-oriented programming at its best, I guess. Yeah, and also showing what you can do just with browser elements. So the canvas is something that's built into all modern browsers since HTML5, which was ages ago, but I forget exactly when. So yeah, and that's just a very simple example. So I'm sure we could go on to create a lot better 3D graphics and stuff using this. And, essentially, it's a little physics engine as well, right?
Yeah.
So can you create 3D graphics with this?
Yeah, there's a 3D function. There's 3D functions on that.
Oh, yeah. Really interesting, really powerful. Thanks for the demo. I think still had one more before you're out of the hot seat.
No, it's amazing that the solving render real time.
Yeah.
So you were gonna say something like, "Oh, I'm surprised the laptop's not burning up." That's what you would say, right?
Thank you, Kieran. Thanks a lot.